So welcome, folks, to today's webinar. We're going to be talking about H2O Driverless AI and Intel DAAL. And we've been collaborating with Intel on an initiative called Blue Daniel. And we've been doing this for about 6 months. I think we're in our second phase of Blue Daniel. And part of that is looking at how we can leverage the best of Intel, both from a hardware perspective, chips and memory, and from a software perspective. So today's webinar will provide a quick and short introduction to driverless and kind of how we're working together with this notion of recipes. So we'll talk about what is a recipe, how it works, and how does the driverless AI and Intel recipe work together. Priti will be providing an overview of what is DAAL, and then actually get to see a live demo, and we'll have some question and answers at the end. So without further ado, so if you're sort of new to H2O, or this is the first time you're joining a webinar, we're a startup based in the Silicon Valley. We've been around for almost 8 years. We just recently received our Series D funding. We have 2 main product lines: our H2O open source, that's used by over 18,000 organizations. And we have an automatic machine learning platform called Driverless AI, which will be the focus of today's webinar. Our team is made up of a series of experts from around the world, from data scientists, Kaggle grandmasters, distributed computing. And our mission is to really focus on democratizing AI for everyone. With regard to that, our software is now being used by, almost half of the Fortune 500, very strong in banking, insurance, and in healthcare companies. We have a very active community of data scientists. We actually have our annual H2O World coming up in New York, October 22nd. I'll have a slide at the end if you want to check that out. And a very active meetup community, so you can always find a meetup in a nearby city to you. And we have a growing ecosystem of customers, many of them who are, you can see their case studies from our website. So H2O is recognized as an AI leader by various different analysts, from Forrester to Gartner. We've won some recent awards both for InfoWorld and Inside Big Data as a leader in the AI space. So as folks start looking at building out their AI strategy, one of the things we want to focus on is helping to accelerate and make it easier for folks to start making their company into an AI company, right? So some of that, is clearly leveraging the best in open source from a machine learning perspective, but also we want to make it just easier, faster, and more cost-effective to kind of get to getting value out of machine learning. We're seeing machine learning being used across many different industries: financial, healthcare, telecom, and lots of different use cases. And as folks start using AI, one of the things that you need to start with first is the data. Looking at different customer interactions, experiences, the time things are happening, data from any and all sort of sources, whether it's, in your backend cluster, in your regional environment, from a mobile device. And as folks are looking at building an AI solution, and we've been working with many customers over years, we've sort of noticed 3 main challenges. The first and foremost is talent, right? Finding these data scientists, these machine learning engineers who have the skills to build these, it can be sometimes challenging. And not just finding the data scientists, but getting a data scientist with a particular skill level to produce the accuracy that the business is demanding. The other thing is the challenge around time, because if you can find these data scientists, it could take a lot of time to get a model into production, right? Because it's not just one model they're building; 10, hundreds, and even thousands of models, and so that time can be very tedious. Even after you've sort of gone through the sort of process of doing this, sometimes it's time just in compute time. So can we accelerate the compute time? And that's where we're kind of been working with Intel to kind of make that even better. And lastly is, as we're looking at taking machine learning into production and kind of having the model make decisions for the business, we need to have trust in what it's doing. And sometimes, the data scientist team can kind of quickly if you have the time and the talent, now you need to convince those business decision makers, or sometimes there's regulatory requirements that you need to go to further process to explain the model before you can actually put it into production. So with that, we've sort of come up with a product called Driverless AI that's really focused on sort of automating this whole machine learning workflow process. So what it kind of looks like really quick is you can kind of connect to various data sources. I think at this point we have over 14 different connectors, whether it's, a Hadoop system, a relational database, or a cloud storage or database. You bring in a table-like structure or IID data. Driverless AI is focused on supervised learning, so you'll have some kind of example or label that you're going to follow, in this case a Y, and a collection of features, which are your X, or a collection of columns. And then you go through this automatic model optimization, where you select different algorithms, or the tool actually selects different algorithms, does feature engineering, does model hyperparameter tuning in an iterative way, where you kind of build a leaderboard of the best model, right? Out the other end, you can kind of get explanations for the model, get automatic model documentation, and if you're good with that, you have a scoring pipeline that includes the model and the feature engineering ready to go to evaluation for production. And so, that's where Driverless AI really fits in. This is automatic machine learning platform. It uses AI to do AI. It delivers not just the insights, but the interpretability, the explanation sort of behind it. So part of the focus of the webinar today is, before 1.7, this gray box that you see here in the middle was really sort of a closed ecosystem. With Driverless AI 1.7, now it's an open ecosystem. And what that means is it's extensible for the types of algorithms that's considered, the transformations or feature engineering that can be leveraged, or the scores, how it's actually being sort of optimized. And the way that's being extended is this: we have this notion of recipes and bringing your own recipes. So let me talk a little bit about what is a recipe. So a recipe, you can think of, again, that we just saw that flow, that pipeline. In that gray box, there's a whole collection of little building blocks, or we call them recipes, to kind of produce a model. And what's happening is those building blocks are used to do that optimization. These building blocks are little Python code snippets. And what's happened with 1.7.0 is we have now made that extensible and open. And because, open is very core to our company. And so the way we open it up is we have this notion of bring your own recipe, right? BYOR. And this allows domain scientists to solve their problems faster with more precision by adding their own expertise, basically making it extensible, right? So you can use your own recipes, or you can do it in combination with the existing recipes that are out of the box with Driverless AI, and you can include these customizations. And this allows you to gain a control over the optimization and influence that optimization to hopefully be able to produce even a better model. So as we look at the types of recipes, they really come in a few different areas, right? These recipes are used to kind of build a model to be able to solve a business problem, right? So these recipes can either be transformations or feature engineering, right? They can be algorithms. And so in this case, we're going to focus on Intel and DAAL as a new algorithm that we want to bring into this ecosystem, or scores, right? Where we want to, what is the thing that we're optimizing for? So as we look at bringing your own recipes, you can either bring in new feature engineering recipes, new optimization functions, right, or the cost or loss function, and lastly, new algorithms, right? And this is where DAAL is coming in. And we're doing this in an open way. So actually, you can visit our GitHub repo right here and see more than 100 recipes that have already been sort of contributed to the open source. And amongst that, you'll see different models. In the models, you'll find actually the DAAL recipe. So now I want to turn it over to Priti so that she can start explaining a little bit about DAAL and how the integration works, and hopefully get to a quick demo. So let me transfer over.
So thank you, Rafael, by the way. So we just saw what are the capabilities that Driverless AI can provide for all the data science practitioners to bring their own algorithms into it. So in the later part of the presentation, we'll talk about how Intel is partnering with H2O in order to bring all of our optimized libraries and then accelerate model building process on the driverless AI platform. So before going to that, mainly the next part of the presentation is going to involve Intel's offerings on classical ML in general, mainly introducing our optimized data analytics library called as Intel DAAL, and then just walking through some of the core concepts, and then introducing some of the key aspects and then benefits that comes out of this library. And like I said, the work we are doing with H2O to leverage this library on driverless AI platform. So Intel DAAL is Intel's high-performance data analytics library, optimized using Intel's performance libraries like Intel MKL, Intel CBB, to support classical ML modeling process, supporting various data analysis stages, like you can see in the bottom, all the way from pre-processing, transformation, analysis, all the way from model building to decision making. So the library itself comes in 3 different APIs. We support fully functional Python, C++, and Java API. One of the key aspects of this library is that we've introduced this newly built high-level API called DAAL for Pi, which is very simple to use, especially for a Python for a Python user, it can be seen kind of very similar to scikit-learn API. So in addition to simplicity, we also provide optimized algorithm to maximize CPU utilization. You can pretty much see it as an API which is scikit-learn optimized for CPU. So another key highlight that we have here is we have our own distribution of Python called Intel Distribution for Python, where we package CPU-optimized libraries around the data science domain. And in this distribution, we offer DAAL for Pi optimized scikit-learn. So we have DAAL for Pi as one component, and then we have scikit-learn itself, which we provide as part of this distribution that is optimized with DAAL for Pi. So users can experience out-of-the-box DAAL for Pi benefits by just using plain scikit-learn. So on the right-hand side, you can see what are some of the new features that we've introduced recently. We have rapidly growing set of ML algorithms supported in this library. And some of the new algorithms that we've introduced is our own optimized classification and regression XGBoost. And then we have our own optimized random forest, which we call a decision forest as part of this DAAL for Pi package. So as for the way that we distribute this library, we have several channels, and one of the primary channels through which we distribute is Anaconda, and then PyPI, and then now we have started distributing all of these through the custom recipe feature on H2O Driverless AI as well. So this is a high-level representation of our software stack to deliver accelerated machine learning experience to data scientists. And this kind of gives an idea of the level of abstraction we are able to provide for easier adoption. So as you can see, the core component here is Intel DAAL runtime that lies at the very bottom. And on the top of it, we have the high-level API called as DAAL for Pi to basically enable, like I said, Python users with the ability to use any kind of computation modes very easily. I believe I just skipped an important slide here. Yeah, this was a slide that was supposed to come right after the introduction. So this is a very unique feature that we offer as part of Intel DAAL. That is, Intel DAAL comes in many flavors. The algorithms that is built on Intel DAAL, they come in 3 different flavors. One of the most common processing mode is the batch processing mode, which is serial execution. In addition to that, we have algorithms that support distributed processing and online processing. So everything with very trivial code changes using DAAL for Pi, with a very Pythonic feel that you can get by using all of these modes. So as you can see, like I said, there is distributed and online processing modes. So based on the type of hardware resources you use, you have the ability to quickly plug into different processing modes using DAL4Pi library. So let's just say you want to scale your ML workload in a cluster that is based on MPI or Hadoop or Spark frameworks. So you can get to use the distributed processing algorithms that we have in addition to serial execution. So also, or let's just say if you have like limited RAM space, and then you want to just keep, you're able to just load part of data into the RAM and train. So we have streaming support for that. So where you just load data chunks that you want to train and then dispose the data and load back new chunk of data and keep retraining your model. So these are like different flavors that we are able to provide in DAL4Pi and with a very trivial extension to your code base. So as you can see at the bottom, there is just one line of a code snippet that I have for all of these processing modes. So in order to enable distributed, all you have to do is just distributed equals true and then streaming equals true, and then your the mode of execution quickly changes based on what kind of execution or computation you want to do in the backend besides just running a serial execution on a single node. So again, coming back to this slide, like I was saying, this is the software stack that we have, and the core component being the Intel DAAL, and then on top of that, we have the DAL4Pi API to basically enable Python users to kind of accommodate all of these different processing modes at ease. So for further abstraction on top of DAL4Pi, we have scikit-learn as well. So let's just say users don't want to, they want to continue doing serial execution. They just don't want to scale their workloads, or they don't want to use our streaming mode. They can just use their existing scikit-learn library and then just get 100% acceleration as to just using DAL4Pi, everything out of the box. Just continue using scikit-learn, just no code changes required, and you basically get all the benefits of our very main core component responsible for all of these accelerations, that is Intel DAAL. This is just a more detailed breakdown of our stack. As I mentioned earlier, Intel DAAL is designed primarily based on Intel MKL and Intel's threading library called as Intel TBB. So since it's possible to scale workloads in a cluster with Intel DAAL, as you can see, Intel MPI can get easily plugged into Intel DAAL and DAL4Pi. And then as part of our Python distribution for people who are using DAL4Pi, Intel MPI is available for free. So they can use the more optimized MPI engine that Intel delivers, and then everything is free when you just install DAL4Pi. And all of these benefits and all of these accelerations, this library, you can install it in just one line command if you're using a Conda package manager. So all you have to do is just hit the command Conda install DAL4Pi and then get the DAL4Pi package from Intel channel, and all of the runtimes and all of the core libraries that is responsible for the accelerations and then the benefits that you get out of it all comes packaged as part of DAL4Pi, completely abstracted from the user. So I was just telling that we have in our own Python distribution, we have scikit-learn, which is optimized with DAL4Pi. But then what are the different ways that you can actually use this DAL4Pi enabled scikit-learn? So as I mentioned in one of the slides, we ship our own Python distribution with all the accelerated packages, including scikit-learn, mainly for the data science domain. So you just have to install Intel distribution for Python, and then the scikit-learn that comes in this distribution has DAL enabled by default. Or let's just say you don't want to use our distribution, you just want to use with scikit-learn that comes out of the official build, which is written purely based on Python. So you can just continue using scikit-learn, but you can actually do a monkey patch to DAL4Pi. So when you install DAL4Pi, let's just say you have scikit-learn, and then you install DAL4Pi, and now you want to use DAL4Pi accelerations with scikit-learn. That is the stock version, written purely using Python and no optimizations at all. It's again very easy for you to quickly plug in. Just do a monkey patch on the command line as shown here. When you're executing your Python script, just put the DAAL4Pi runtime along with scikit-learn. So when the script runs in the back end, scikit-learn is basically going to use all of the optimized classical ML algorithms that we've kind of accelerated in DAAL4Pi package. And another way for you to do is also programmatically change it. So just go to your script. Instead of just doing import scikit-learn, you have to just do DAAL4Pi.scikit-learn. This is only when you're using the stock scikit-learn, that is the official build of scikit-learn. But then if you're using the scikit-learn that comes out of our Python distribution, you don't have to worry about all that, because in the backend we've already done all the integration, so no monkey patch or anything required. So this is pretty much the landscape of the ML library and the ML optimizations that we've done in scikit-learn, and then packaging it together in our Python distribution. So in the next slide, we'll see some of the performances that we can get, some of the benchmarks that we've run. So here, as you can see, the slide itself explains. So we ran tests on about 70,000 samples on k-means with different, computing initial centroid algorithms. Then, as you can see, you can get at least minimum 20 times faster using the Intel optimized scikit-learn, which is optimized with DAAL4Pi, as opposed to the stock scikit-learn, which is the official build. So all of this accelerations is just out of the box. You don't even have to use DAAL4Pi. It's just coming straight from scikit-learn. So these are again additional some benchmarkings on training and predictions that we've run on some of the top ML algorithms. As you can see, the Intel optimized scikit-learn is just stays as competitive as the performance against its native counterparts. So if you can see, you can get as much as 70 to 100% efficiency, just like using a native code. And this is all coming out of scikit-learn that is optimized with DAAL4Pi. So the dark blue ones here on this plot is the scikit-learn optimized with DAAL4Pi, and the blue ones are the stock scikit-learn, which is just Python-based. So you can barely see that they are only up to 10% as efficient as native code, but their the DAAL4Pi counterpart scikit-learn can achieve as much as I said, 70 to 100% efficiency here. This is just another slide basically showing how well DAAL4Pi is able to scale in distributed mode. So just how competitively it can scale as the workload increases in terms of nodes and as the data size grows. So all of this in just one line command with just a very trivial extension called as distributed equals true. This is just showing how easy it is to basically write a code and then build a model using DAAL4Pi. With DAAL4Pi, you just have to import, just like scikit-learn, you would just import k-means and then pass the parameters and the clusters and all other required arguments for you to build a model and then find the centroids. And then the next step is compute. Next step is get the centroids and then compute the final centroids. So this is the batch processing on a single node. In order to scale this workload across multiple nodes, it's a very similar code. All you have to do is just pass the flag distributed true, and then just pass how many other processes you need, and then just do the data splits so that when you launch an MPR run command, it's just going to pick the chunk of data that you want and then processes that in parallel and compute centroids using the scaling factor that is running right underneath our distributed version of the DAAL4Pi library. So this is just again showing how easy it is to also do the streaming processing. So just read the data and then so just read chunks of data, throw the data out once when it's trained, and then again retrain your model, and then finally you get the compute model. So this can be used in many cases. Like one of the cases that you can basically use this is, let's just say you have trained your model, you want to come back after another month and then retrain it on an existing model. So instead of retraining it from the scratch on the entire set of models, you're just going to have to retrain on the new data that arrives. So these are some of the kind of use cases where streaming plays a really huge part in saving a lot of time and compute resources for users training a model. So this is just like the list of some of the top classical ML algorithms that we support in Intel DAAL. The typical linear ridge regression. We have decision forest. We have decision tree. Decision tree is nothing but the most popular random forest algorithm. And then we have our own version of XGBoost. And then we have knife-based KNN SVM. We have an unsupervised k-means, collaborative filtering using ALS. So based on the heavily adopted ecosystem, we have picked up all of these algorithms and then made sure that we build it in a more optimized way for CPU, and at the same time kind of exploring different processing modes, and then kind of helping users to leverage their CPU resources and then get benefits on the processing modes that they want to select to run these algorithms. So that's a very brief introduction to Intel DAAL and some of the key highlights of Intel DAAL. So coming back to H2O, as Rafael mentioned, we have partnered with H2O to introduce several optimization for our new Intel second generation Xeon processor. And one of the main efforts is that introducing Intel DAAL accelerations into H2O's driverless AI platform. So we are basically doing this, like Rafael said, we are using the custom recipe feature that has been introduced recently, where you can bring your own recipes and then leverage all of the benefits that comes out of this automated machine learning platform on the driverless AI. So right now we are basically kind of enabling data scientists who are using driverless AI by building custom recipes on algorithms for gradient boosting and random forest with our optimized Intel DAAL library. So by building these H2O driverless AI recipes with our optimized algorithms, we are able to see nearly about 3.5 performance gains in some of the most popular algorithms. So mainly these testings were all made on Cascade Lake processor. As you can see, you can expect 4x scale, basically that is coming out of our Optane DC persistent memory that has been newly introduced in our Cascade Lake processor. So this is just a slide that shows an overview of how easy it is to get Intel DAAL and then all the accelerations in Intel DAAL in driverless AI. So the first thing is you just have to get the driverless AI product, and then you just have to go to the recipes and pick the Intel DAAL recipe that our internal team is basically working with H2O to introduce all of these accelerations into this GitHub repository. And when you get this, all you have to do is in your driverless AI dashboard UI interface, when you're loading the algorithms on which you want to train your data, all you have to do is just upload the custom recipe, that is the DAAL_trees, which I will be showing shortly in this demo. Then just click on the recipes, select the recipes or the algorithms that actually comes out of these recipes, and then start building a model. So we ran a few DAAL experiments on primarily a data set called, which is public, called single family loan performance data to basically train a model where we could predict if the borrowers would default the payment for the following year. So for this demo, I would be using a very small sample of this just to show how to import these recipes and then run algorithms based on this data set. The data set basically includes information such as the borrower's credit score, or unpaid unpaid principal balance, what is their current delinquency status based on how many months they have been defaulting their payments, and other typical loan information in order to be able to see what is the probability of them paying again defaulting in the following year. So just to give a quick overview of what we are going to show in this demo, we will just be we will start running the driverless AI, import the DAAL recipes, and use the algorithms to train a model on a mortgage data set. So let me quickly switch to the screen where I would want to show the driverless AI recipe. Oops, I just lost connection here. Okay, I have a session running, so give me a quick second. Let me start another instance. So I have a new AWS C512X instance that I have launched, which is based on our new Xeon processor. So I have driverless AI product already installed here. So now I'm just going to start the driverless AI service. And then it's launched, and it'll be available at the local host. Is it 1234? So it's that simple for you to get Intel DAAL on driverless AI. So just launch just run the driverless AI, and then go to your local host. Look at 12345 port number, and then just log in. So like I said, I would be just using the mortgage data set. So the entire mortgage data set on which we ran all of these experiments were about 8 million records with 46 features. So I just made a small data sample for this demo. So what I'll do is, so now the data set is imported. So it's pretty simple. So there are different ways that you can actually import your data set. You can use cloud, you can use HDFS, Hadoop file system to get your data set. So I have a data set here. So let me click on predict and then launch a new experiment. So this is the UI interface. All you do is just based on clicks, and then you get the statistics. So like I said, it's a very small sample that I'm running. It's just on a 500,000. So I will just launch the experiment, and then I'll show you what happens at the end, and then what were the results that were captured and the observations that were made. So you can also add a test data set here. You can drop some columns that you don't want to be part of this training, and then I select the target. So like I said, I will have to select the delinquency to see if the user would basically default his payment in the following year. And then this is where you do most of the settings here, the expert settings tab. So click on the tab, and then go to the recipes, and then just look at what are the algorithms that are included as part of this train process. So these are the algorithms, XGBoost, Slice, GBM, some of the top-notch algorithms included as part of this core product. But then how do you import custom recipes? Especially, how do you import the ones that are introduced, DAAL, which is optimized for CPUs? So just go to the driverless AI. Just go to the driverless AI recipe. And then pick the recipes that you want. So here is where we have the recipes that we've introduced, which has optimized XGBoost and then optimized random forest. So just get the link of this. And then you have a small feature here where you can get custom recipes using different ways. So the way that I'm going to choose here is I'm going to use the URL that I just selected, which is basically a Python script that's going to build the DAAL algorithms that is suitable and compatible to be used on driverless AI platform. So like I said, this will just take like a couple of minutes for it to load. We've introduced the optimized XGBoost, which is called as gradient boosting trees in Intel DAAL. And then we have random forest, which is called as decision forest in DAAL. So we are continuously working on introducing additional capability. Right now we have like fully functional regression models that are supported. So we are adding more features to the classification model as well. So in our next 2020 release, we are introducing several support for XGBoost and random forest. So such as computing classification based on probabilities and supporting distributed and streaming mode where people can just use DAAL for Pi in a cluster environment. So the custom recipe is almost getting loaded, and then it's just running like some tests. So we have DAAL tree, which is the DAAL gradient boosting, and then we have DAAL forest, which is the random forest in driverless AI. So I'll go to the recipes. And now, if I look at this, in addition to the core products, I have additional 2 algorithms that are being imported, which is DAAL forest and DAAL tree. So now, there are 2 ways you can actually run this. You can either select all of these algorithms and just leave the driverless AI engine to basically select what is the winning algorithm. Like Rafael mentioned, it gives you the leaderboard on what are the top algorithms that is best suitable for your use case. Or if you kind of already know what is the kind of algorithm that you want to run, but all you're worried about is tuning it and then optimizing the algorithm and then improving the model quality, you can just choose specific algorithms that you want and then you run. So you can just uncheck and then just select DAAL forest and DAAL tree and then run, or you can check everything and then just run it. And but then it's the trade-off is it's just going to take a while because it's going to pick every algorithm, tries to find tries to converge and then does hyperparameter tuning behind all of these, and then it just takes a while. What is the optimal algorithm, and then what are the optimal settings that you need in order to run this. So I'll just click done here and then save this. And I'll just launch an experiment. So now the experiment is basically going to start running, tries to identify all of the features, tries to do some level of feature engineering depending on what are the different column types that you have. And after that, you'll see a small screen that's going to appear here that's going to basically start running these algorithms over every iterations based on the accuracy time that you have set. So as you can see, light GBM, it starts training with light GBM, and then it computes the mean square error. So basically what the outcome that you're going to predict is between 0 and 1. So within the range of 0 and 1, anything that is closer to 0, he's a more safer borrower there's more likely that he might not default than a more risky borrower. And then the institute knows what is the next necessary set of actions that they want to take. So it starts training light GBM. So this goes on for like about, let's just say, an hour to train. And then finally, you can even look at the residuals and then what is actual versus predicted. Several controls and several navigation, several features available on top of this to constantly keep looking at and then gaining more insights of what is happening around this experiment. So while this experiment is running, I can quickly show you the same experiment that I just ran a while ago, and then while it completed, I would just want to show the leaderboard on what were the final set of algorithms that were selected as some of the winning algorithms, which could be deployed for you to actually score it on a different data set, or even deploy it into an application where you want to actually start predicting for any new incoming data set. So as you can see, the top 2 algorithms in this experiment were XGBoost and DAAL forest. This was basically trained on, like you saw, selected all the algorithms. It included DAAL tree, DAAL forest, XGBoost, GBM, Light GBM, and all of that. So this is the winning algorithm. So now that you know this, you know what is the kind of algorithm that you want to further train. What is this? So here you have like different tabs which you can basically select to take what necessary actions you want to do after training this model in the same driverless AI platform. So this is mainly showing people how DAAL is being competitive in terms of giving you a very qualitative model. So instead of, let's just say, using XGBoost, there's an opportunity for you to use a DAAL equivalent to get the same model quality that you would expect running the algorithms that are as part of the core product, and at the same time, it is much faster. So here, this took about 1 hour, but it ran on all the algorithms. But then I have a slide deck. I'll just move back to the slide deck to show you that where we ran individual experiments on specific algorithms to see how long it took to train the model. So these would be helpful for you if you know, like I said, what is the algorithm that you want to run. So instead of leaving the engine to just see what is the algorithm that you need to select, you can just select the ones that you know works for your data set, and then again selecting the DAAL equivalents that are much more optimized and gives you faster results. So this is again just a screenshot of, so like I said, the demo that I launched is just like about 500,000, very small sample of the data. The actual experiment that we ran several times was actually the big 2000 data set, the loan performance data for all of the quarters, which is about 8 million records. It took, I would say, about nearly 3 hours to train on this on all of the algorithms, and then finally on the 8 million record, DAAL forest and DAAL tree came out to be the winning algorithm with better MSE score to basically predict the continuous value from 0 to 1, that is whether the borrower is at a high risk or low risk between that range. So like I said, those experiments basically deal with DAAL being the winning algorithms on this data set. But we ran a few experiments to basically pick algorithms from DAAL and then pick algorithms from the core product and then kind of compare how fast each of these individual algorithms perform. And then as you can see, the first one we ran an XGBoost algorithm, which took about like nearly 2 hours before we aborted the experiment on the 8 million, that is on the big data set that we had on the same mortgage data set. The next experiment that we ran to see if we would be able to complete the experiment is on a GPU, again on an AWS instance. The experiment the XGBoost on mortgage data set experiment completed successfully with the validation and test score of 0.081. And the final experiment that we ran is based on the DAAL algorithms, that is the DAAL equivalents of XGBoost that came from this newly introduced custom feature on driverless AI. We were able to train in under 1 hour, which is around 40 minutes, and then with a better MSE score here. So it is nearly about 3 times faster than the competitive accelerators on which we trained this data set. And then when you're running it on cloud, you can definitely expect a much lower TCO. So for users to be able to reproduce this experiment on driverless AI, I have given links to the data sets at the bottom. And then the slide deck will also be shared with the steps I had done in the past to actually just reproduce it on a hands-on session. And also there is a video that's going to actually go out as part of the webinar material, which basically illustrates from how to start a driverless AI, import Intel DAAL custom recipe, and then finally stop the service. So yeah, that is pretty much I had on Intel DAAL and the benefits that we get on driverless AI.
Thanks, Priti. I wanted to share, and I think there's a couple questions that are starting to develop in the chat. I did share a couple slides before we sort of transition to question and answers, just a little bit on how people can kind of get started. So if folks can see my screen again. So if you want to learn more about our open and extensible machine learning optimization, bring your own recipe, this is the URL you can check out. We'll be sharing that at the end of the webinar, so you can kind of look at that. If you just want to get started with Driverless AI, we have this whole collection of tutorials that you can leverage, and we have a free 2-hour cloud environment called a test drive. And so that'll get you up and running in an environment within about 6 to 10 minutes. And then you can kind of go through a collection of 5 tutorials. And you can actually use it multiple times. If you ever have questions, or hopefully you can post a question here, we can have a discussion here. But online, we also have a community where you can kind of post questions via Slack and get more help. And lastly, if you're in New York or near New York, or want to get learn more about the latest and greatest, both in the open source H2O and Driverless AI, definitely check us out at H2O World in New York on October 22nd. And here's a link. So I think that's what I had sort of to share additional resources. Now we have a few minutes for sort of question and answers.
Yes. Thanks, Rafael. So the first question that we have, is it okay to train a model on a non-Intel architecture?
So Patrick, do you mind repeating? I think you cut out in the middle of that sentence.
Yeah, I think I might be echoing too. So maybe you just read the question so I'm not echoing anymore.
Okay. So I think the first question is it okay to train on Intel and deploy the model on a non-Intel architecture? So I can answer it from the H2O AI sort of perspective. So you can train the model using Driverless AI, and then when you go to deploy the model, you have 2 options. You can either deploy it via Python, or you can deploy it via a Mojo. And the Mojo is a model-optimized Java representation of the model. And when you deploy via Mojo, you have a couple of different runtimes. You have a Java runtime, you have a Python runtime, an R runtime, and wherever that runtime can be deployed, then you can do sort of inferencing, right? And so that's from the H2O perspective. Preeti, do you have any other insight from the Intel perspective as far as deploying DAAL models?
Yeah, definitely. So Intel DAAL models are definitely compatible across the architectures, but then our optimization notice does say that all of these libraries, they basically operate on the instruction set that we have as part of our architecture. But then if you are running it on a different architecture which supports a different kind of instruction set, maybe a lower instruction set than Intel, you might not be able to experience the same performance benefits as you would get in Intel architecture.
Thanks, Preeti. Any other questions for folks? Feel free to go into the Bright Talk and go into the question section. Okay, Patrick, there doesn't seem to be any other questions in the queue, so I'll give it back over to you.
Great, thanks, Rafael. So just want to say thank you to Rafael and Preeti for taking the time today and doing a great presentation. I'd also like to say thank you to everyone who joined us today. The presentation slides and recording will be made available on our Bright Talk channel, as well as some additional links to Driverless AI resources. So just want to wish you a great rest of your day, and thank you again for joining.